16 billion miles from home, a machine is dying in the cold, its power fading, its voice growing weaker, but still. It calls. Every 23 hours, a whisper reaches Earth, fainter than a snowflake landing, proof that somewhere in the darkness between stars, Voyager 1 is still alive. If you're fascinated by humanity's most distant creation, stay with me. And if this story moves you, consider hitting that like button. It helps others discover Voyager's journey too. This is the story of the loneliest object in existence, the farthest thing humanity has ever sent. A machine built to last 5 years that's been traveling for nearly half a century. And soon, very soon, its signal will stop forever. 1977. The planets aligned, not metaphorically. Literally, Jupiter, Saturn, Uranus, Neptune, moving into a configuration that happens once every 175 years. A cosmic window. Launch at the right moment, and a single spacecraft could visit all four giants, using gravity to slingshot from one world to the next. The mission planners knew this chance wouldn't return in any of our lifetimes, so we built two machines, Voyager 1 and Voyager 2. Each the size of a compact car, crammed with cameras, spectrometers, magnetometers, everything we could pack into a frame that would survive the journey. The design life, 5 years, maybe 10 if components held out longer than expected. Get to Jupiter, fly past Saturn, send back data, then probably fail. That was the plan, but before launch, someone had a different idea. What if Voyager didn't just gather data? What if it carried something else, a message, not for us, for whoever might find it, thousands or millions of years from now? They created the golden record. A 12-inch disc, gold-plated copper, encoded with sounds and images from Earth, a mother's voice, a child laughing, music Bach, Chuck Berry, Javanese gamelan, Peruvian panpipes, greetings in 55 languages, the sound of wind, rain, fire, a heartbeat. Even the recorded brainwaves of a woman in love, her thoughts compressed into pulses, destined to drift through the void for eons. And diagrams, maps showing our location in the galaxy, etched in lines and symbols, hoping that some distant intelligence might understand. It was a message in a bottle thrown into an ocean with no shore in sight. On September 5, 1977, Voyager 1 launched from Cape Canaveral, 38,000 miles per hour, fast enough to escape the sun's gravity forever. Nobody knew how long it would last. Quick question for you: if you could send one thing on Voyager that represents Earth today, what would it be? Drop your answer in the comments. I'd love to see what you'd choose. March 1979, Voyager 1 reached Jupiter. It passed within 174,000 miles of the cloud tops, closer than any spacecraft had ever been, and what it saw changed everything. The great red spot, larger than Earth, churning in Jupiter's atmosphere like a wound that never heals, lightning flickering in the darkness. Auroras dancing at the poles, and the moons, Io, covered in volcanoes, active volcanoes. The first time humanity had ever witnessed volcanic eruptions beyond Earth, plumes of sulfur shooting hundreds of miles into space, Europa, smooth, cracked ice hiding an ocean beneath, Ganymede, Callisto. Worlds we'd only seen as dots of light suddenly revealed in intimate detail. Voyager didn't stop to admire its work. It used Jupiter's immense gravity to accelerate, bending its trajectory toward Saturn. November 1980. It arrived, the rings, thousands of them. Braided, kinked, shepherded by tiny moonlets we never knew existed. It flew within 4,000 miles of Titan, Saturn's largest moon, a world shrouded in thick orange haze, hiding lakes of liquid methane beneath clouds of organic chemistry. And then Voyager's official mission ended. It had done everything we asked. Visited two giant planets, sent back data that would take years to analyze, revolutionized our understanding of the outer solar system, but its trajectory, bent by Saturn's gravity, was now angled upward, out of the plane of the solar system, away from the planets, toward interstellar space. We could have shut it down, turned off the instruments, let it coast in silence. Instead, we kept listening. February 14th, 1990, 13 years after launch, Voyager 1 was now beyond Neptune's orbit, 3.7 billion miles from home, and we gave it one final task: turn around. Look back, take a picture. The camera swiveled, pointed toward the sun, and there, caught in a beam of scattered sunlight, was Earth, a pale blue dot, less than a single pixel, barely visible. Every human who ever lived, every empire, every war, every act of love, every moment of suffering contained in that speck of light. Carl Sagan, who helped design the Voyager mission, later wrote about that image. Look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward. Every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader. Every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. After that photograph, Voyager's cameras were turned off. There was nothing left to photograph, only darkness ahead. And if that perspective resonates with you, consider subscribing. There are more stories like this, stories that remind us how small we are and how much we've dared to reach beyond ourselves. August 25th, 2012. Voyager 1 crossed a boundary, the heliopause, the edge of the sun's protective bubble, where the solar wind collides with the interstellar medium. For the first time, a human-made object entered interstellar space, and it kept going. Today, Voyager 1 is nearly 16 billion miles from Earth, moving at 38,000 miles per hour. Every second, it travels 17 kilometers farther from the only home it's ever known. Out there, the sun is just a bright star, not bright enough to warm anything. The light reaching Voyager is 30,000 times dimmer than sunlight on Earth. The temperature, -250 degrees Celsius, just a few dozen degrees above absolute zero. Voyager's exterior has been frozen for decades, its metal skin, its antennas. The golden record bolted to its side, locked in ice that will never thaw. Inside, small heaters struggle to keep the electronics functional, but those heaters are being shut off one by one to conserve power. The spacecraft is surrounded by nothing. The density of interstellar space is about 1 atom per cubic centimeter. Voyager could travel for thousands of years without hitting anything solid, but it's constantly bombarded. Cosmic rays, high-energy particles from exploded stars, from collisions in distant galaxies, streak through Voyager's circuits. Flip bits in its memory, corrupt data. Voyager's computers detect these errors and correct them, but over time the damage accumulates. And in that darkness, in that silence more complete than any human has experienced, Voyager still transmits. Every day, Voyager sends a signal, 22 watts. About the power of a refrigerator light bulb. The signal travels at the speed of light, takes almost 24 hours to reach Earth. By the time it arrives, the power striking our antennas is 10 to the -16th watts, 1 part in 10 quadrillion. NASA's Deep Space Network listens. Massive radio dishes, 70 meters across, in California, Spain, and Australia track Voyager constantly. And barely, just barely, they can hear it. The signal carries data, temperature readings, particle counts, magnetic field measurements, information about the space between stars, and a heartbeat, telemetry, data about Voyager itself, its orientation, its power levels. Whether it's still alive, when we receive that signal, we know Voyager was alive 24 hours ago, then we wait for the next one. November 2023, something went wrong. For 46 years, Voyager had spoken clearly, but suddenly the data became garbled, unreadable. Like listening to a voice replaced by a monotonous dial tone, it was still transmitting, still listening, but it couldn't tell us how it was doing. 15 billion miles away, a single chip in its flight data system had failed. A piece of hardware designed in the early 70s, finally worn out, maybe from a cosmic ray, maybe just from age. The engineers at JPL pulled out paper schematics, yellowed at the edges, signed in 1974. They had to write a software fix for a computer with less memory than a car key. Every command took 23 hours to reach Voyager, then another 23 hours to see if it worked. For 5 months, we didn't know if we'd ever hear its voice again. But we fixed it. We moved the corrupted software to a new section of memory, brought Voyager back online, but the glitch was a warning. The mind is still there, but the body is failing. If you're amazed by the ingenuity it took to save Voyager from 15 billion miles away, a super thanks would mean the world. It helps support deep dives like this one and keeps Voyager's story alive. Voyager 1 runs on 3 radioisotope thermoelectric generators, RTGs. They convert heat from decaying plutonium-238 into electricity. At launch in 1977, they produced 470 watts. Today, 220 watts. They lose about 4 watts per year. By 2030, Voyager will have less than 200 watts, not enough to power all its systems. So NASA has been making choices, heaters shut off, instruments powered down. In February 2025, the cosmic ray instrument was turned off, not because it broke, but to keep the mission alive a little longer. The cameras were shut down in 1990, after the pale blue dot. The plasma science instrument in 2007, the planetary radio astronomy instrument in 2008. One by one, Voyager's systems are going dark. Engineers think they can keep at least one instrument running into the mid-2030s, maybe until 2036, but eventually the power will run out and Voyager will go silent. Not because it crashed, not because something broke, just because it ran out of light. When the signal stops, Voyager will still be out there, still moving, still drifting through interstellar space at 38,000 miles per hour, but we won't hear from it anymore. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of a red dwarf star called Gliese 445. Not close enough to be captured, just drifting past. Silent, cold, dead. During those 40,000 years, almost nothing will change. Voyager will coast at the same speed. Through a void so empty that collisions are nearly impossible, its surface will be pitted by micrometeorites, its electronics will degrade from radiation. The golden record will endure protected, unchanged, and no one will know where it is. By then, Earth will be unreckonable. Human civilization might be gone, transformed. Spread to the stars or extinct, ice ages will have come and gone, continents will have shifted, species will have evolved and vanished, and Voyager will still be out there. A message from a world that may no longer exist. It will drift for millions of years, billions. Long after every star we see tonight has died or drifted away. A ghost, a relic, a monument to a species that once looked up and wondered what was beyond, and built something to find out. Right now, Voyager 1 is still out there, still moving, still transmitting. Every day a signal arrives, faint, fragile, but there. And every time we receive it, we know Voyager is still alive, but that signal is weaker every year. One day, maybe in 2036, maybe sooner, it will stop. We'll wait 24 hours for the next transmission, and it won't come. We'll wait another day, another week, nothing, and we'll know that Voyager has sent its last message. The farthest human object in existence, finally silent, drifting into the void, alone. Forever, we built it to explore, to discover, to reach beyond the edge of what we knew, and it did. It showed us Jupiter's volcanoes and Saturn's rings. It crossed into interstellar space. It sent back the pale blue dot. It became the first human-made object to leave the solar system. and when its power finally runs out, it will drift in silence for millions of years. A messenger from a distant world carrying a message to anyone who might find it, someday, somewhere, in the darkness between the stars. If Voyager's journey moved you, please like this video, subscribe, and share it with someone who needs a reminder of what we're capable of when we dare to dream beyond ourselves. And let me know in the comments, what does Voyager mean to you? Goodbye, Voyager, and thank you for showing us how far we can go.